I am in the Institute of Dentistry. I'm not a dentist, and the reason we do heritage science in the Institute of Dentistry is complicated. I won't really explain it here. But thank you for the opportunity to present some recent work we've done, imaging damaged manuscripts. The work Thank you. The work I'm going to present here today is it's a collaboration between, let's get the slide up. It's a collaboration really between the Norfolk Record Office, Cardiff University and Queen Mary Dental School. We'd established a proof of concept in being able to read old scrolls and rolled up documents. And we were looking really, we'd worked with Antoinette Curtis at the Norfolk Record Office, and she'd given us some provisional material to try to use our virtual unrolling techniques on. And then we'd got the proof of concept down, so we then needed to try it on something real. And so this is how this came about. So Queen Mary University of London is a centre of excellence for X-ray microtomography. We invented it back in the early 1980s. It's very similar to medical CT scans, but it's more suited to imaging smaller objects at higher resolution and with better contrast. The group at the University of Cardiff are experts in computer vision, so they program computers to try to see things that humans can or cannot see, and they are developing the virtual unrolling software. And the Norfolk Record Office is known to many of you. They have the parchment collection. They have a rich and large collection of medieval manuscripts. So the roll that we got from Norfolk Record Office was the Bressingham roll. It's a parchment manuscript. It's an account roll from the Manor of Bressingham dated to about 1408. It's a parchment roll. It was identified for possible conservation during stocktaking of the collection in December 2005. Comments from users on the conservation request form suggested the parchment roll was stuck. You could only unroll a certain amount of it, as is visible on the unrolled section. That's as much as unrolls. It's about 100 millimeters or so that you can unroll. The width of the roll is approximately 270 millimeters, and the total length is unknown because it cannot be unrolled. The fusing of the roll is likely to have been caused by damp storage before it was deposited with the Norfolk Record Office. So it's been sitting in good conditions ever since they've had it, but it suffered at some point. It was probably had a weight or something, or something had been laying on top of it, and that's caused flattening and the issues that you can see towards the middle of the roll. It was known that the ink was iron gall ink, so this made it suitable for our technique. We need some contrast agent, something containing metal, or something with some metallic ions in it to see with the X-rays. So this was a pretty good thing we can attempt. The roll was prepared for scanning by a custom packaging for travel. So it was packaged in Plastizote LD451, which had been formed into a tube and then laced up with 5mm linen thread. Plastizote was known to have no issues in the X-ray beam. You can shine X-rays on it for days. It doesn't appear to degrade. It doesn't give out any degradation products. And it's pretty much transparent in the X-ray beam, so you're not occluding the things you want to see. It doesn't interfere with the image collection. So the final enclosure design is shown in the image there, and it's just sitting on, there's a Perspex button at the bottom which slots into our holding mechanism, so we can manipulate this. The reason for packaging in this way was to keep it safe and secure, and also it was going to be handled by me, an unskilled user. I'm an electronics engineer, not a paper conservator. I'm a fraud here. So the scanning process, the object goes into this machine. The thing does the mouse work? At the time the photograph was taken, it was scanning a tooth. We're in the dental school. But it gives you some idea. The machine it's about 2 meters long, probably about 1.3 meters high. Unlike CT scanning for humans, which require the patient to hold still when they move the X-ray source around, so if you have a CT scan, you hear the clanking and everything going around you. Our scanners require that the object is being rotated between the X-ray source and the camera. The height of the Bressingham roll, if you remember, that's about 300 millimeters. If we just hold that at the bottom, it's likely to wobble. And if it wobbles, it will cause blurring to the images, and it's just not good. So we held the roll in a second polyethylene tube, and then we scanned the bottom half of the roll, and then inverted the roll in the tube and scanned the top half. That minimized the wobble, minimized the amount of scanning that needed to be done. So multiple X-ray images are taken, and then you rotate the object a fraction of a degree between scans until you've collected 360 degrees worth of projections. The total scan time took around 4 days. We collected over 46,000 images and about 120 gigabytes of data. So it's quite a slow process. It then took about a day to convert the collected data into something that you could actually process. So this is it's a sped up time-lapse video of what happens to the scanning. So in this case, the Bressingham roll would be here. This is actually a phantom. The roll is not in the tube at this time. The X-rays are emitted from here, and our camera is this object. What happens is the camera slides backwards and forwards to scan a larger image, and you'll see the roll will rotate and then also move up to collect the next block when this plays, if this plays. So it's fairly quick, it's all over fairly quickly. This was something filmed by the BBC as a very short segment for a TV programme they were making. So you can see the camera slides backwards and forwards. The roll rotates and then moves up and rotates again for more images. In reality, that would be about 30 seconds worth of time, compressed down to a couple of seconds. What do you get at the end of the processing? And the first thing that really came out of this and was useful to the conservators was just this is a virtual slice through the scroll. So if you imagine the scroll is projecting towards you and away from you into the display, and you can see the free end of the scroll. So this is the end that can be unrolled, and then you hit a certain point and you've got where sticking starts to occur, and you have this region that is really very stuck. As soon as we showed this to Antoinette and the other conservators at the NRO, they could immediately see they were justified in not trying to unroll this. It would be very difficult to unroll parchment that is stuck that well. So even before we did any virtual unrolling, we were able to provide a useful service to them and show them it was going to be difficult. The false colours on this are just because the other material in the scan doesn't show up very clearly. I've false coloured it. The yellow is the plastozote. The red is the linen thread. But for the virtual unrolling, the important stuff is the parchment which shows up. And the slightly brighter areas you may see are actually the ink on the surface, but it's quite hard to see in this image. We handed the data over then to our colleagues at the University of Cardiff. I'm going to skip over the magic they perform because it's well beyond my area of expertise. It's just lots of very difficult mathematics. On the output, as you see, is this. So this is a visible image towards the very start of the scroll. And then this is the image as virtually unrolled. So after X-rays, this is virtual unrolled. You can see that there's some noise in the background. This extra texture, if you like, to the image is just caused by lime on the scroll, which is calcium, which is a metal which shows up quite nicely in X-rays. But you can see that areas that appear to have faded out in the visible do appear to be there quite strongly in the X-rays. So the ions are still present, even if the tannin or the darker components of the ink have long since vanished. The lower image is a fragment showing text retrieved from deep inside the roll, so this is towards the center of the core of the roll. It's maybe not as clear to read. It doesn't help it's being blown up to large size on the screen. That makes it a lot harder. If you shrink that down, the archivists were able to read it. So the overall result after a month or so of processing by the wizards at Cardiff was this. So this is the entire length of the roll, but it's only the left-hand third. The rest of the roll would extend out here to give you the full document. The reason only the left-hand third has been worked on so far, the nature of this document, most of the text was on the left-hand side, so that was where we were aiming to get. The center portion is the portion that's really stuck, and that's what these black marks are. They are where the unrolling algorithm fails, and that's where it's stuck. It cannot work out which layer of parchment is which, so it fails. The area that was unrollable before our work, so practically unrollable, was everything here up. So we've retrieved probably about another 70% or so of the roll that was otherwise invisible. The work that was, so then the archivists came in and they read this and they were able to establish things that had gone on in the manor of Bressingham, who had bought land, who had bought wood-cutting rights, who had bought fishing rights, etc. Things that were likely known because they have the roll before this one, they have the one after, so they have a fair idea who was doing what. This just fills in the details for the year they never had. As the image processing algorithm improves, we will be able to, or we envisage being able to unroll the rest of the roll to get the full width. So no more scanning will be necessary. We have the data. The roll is now back in the archives, safe and secure. It's now just a process of getting better programmers, really. I said it would be a fairly quick talk. It is. These are my acknowledgements. We have this published actually in the Journal of Paper Conservation last year. So this is just a quick overview of what we're currently doing. Things we're now looking at being able to unroll are burnt parchment. We're scanning a burned title court roll with the aim of being able to unroll this, and we're also working on film. So, thank you.